In this quick review, we want to talk about expected value. All right, expected value. What is it? Well, here's a formal definition of it. Expected value is the average gain or loss of an event if the procedure is repeated many times. Another way to think about this is it's a long run average if we want to talk about, like, say, a probability experiment. So, like, the first example we'll do is this. Suppose you take a fair six-sided die and you roll it 100 times, 1,000 times, and you record what number shows up each time. What would be the average you would get? Okay, this is what's called the expected value. And so we can compute the expected value by multiplying each outcome by the probability of that outcome, then adding them up. So it's going to look like this. Let's let x with the subscript I represent the individual outcomes. And what we're going to have to do is we're going to have them be numerical. All right, the numerical values of the outcomes. Then that means the probability of x sub I are the corresponding probabilities of those outcomes. So then what that means is the expected value is just this formula. You're going to multiply each outcome times their corresponding probability. And then you're going to add up those products. Well, in mathematics, we're going to use the summation sign. So we're going to sum up each x value times its corresponding probability. All right, let's do one example of this formula. So let's compute the expected value of a die roll, okay? So expected value is equal to the sum of each outcome, numerical value of each outcome, times their corresponding probability. Okay, well, look, what are the outcomes, all right? Well, when you roll a die, you get a 1, a 2, a 3, a 4, a 5, or a 6. And in this very simple example, the corresponding probability for each of these is 1/6. Like, the probability you roll a 1 is 1/6, 2 you roll a 1/6, 2 you roll 2, the probability is you roll a 1, the probability is 1/6, and so on. So I could roll a 1 times its corresponding probability. Plus I could roll a 2 times its corresponding probability. Plus I could roll a 3 times its corresponding probability, and so on. A 4 times its corresponding probability. 5 times its corresponding probability. 6 times its corresponding probability. Well, let's do this. 1 times 1/6 is 1/6. I'm going to leave these as unreduced fractions. You'll see why, because they'll all have a common denominator. 2 times 1/6 is 2/6. 3 times 1/6 is 3/6. 4 times 1/6 is 4/6. 5 times 1/6 is 5/6. And finally, 6 times 1/6 is 6/6. Look, they all have this common denominator 6, so 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21 out of 6. If you do this simple division, what this means is the expected value of a die roll is 3.5. Now, one thing you'll notice immediately is like, hey, I can't roll a die and the number 3.5 come up. That's okay. That's still a long run average. Like, for example, if two people take a test and somebody gets a 79 and somebody gets an 81, the average is still an 80, even though nobody got an 80. That's still the average score. This is still the long run average of a die roll. So it's okay for the expected value to be a value that can't come up. This is still the long run average. All right, I hope this quick review helped. And as always, please reach out to your instructor for additional help and more examples.